Problem 1 on the study guide, practice test, whatever you want to call it. Solve a proportion. To solve a proportion, we're going to multiply the diagonal down, so 1.6x equals the diagonal up, 5.2 times 4.4. All right. That doesn't multiply easily, so I just wrote down what I'm supposed to do, then I'm going to get a calculator to calculate it. So 5.2 times 4.4. So I get 1.6x equals 22.88. So again, cross multiply. I want to say we've done about 50 proportions over the course of this chapter, so this should not be foreign to anybody here. It's pretty much the straightforward way of doing it. And then 1.6x equals 22.88, we divide by 1.6, and that comes out to, if I get my calculator divided by 1.6, it says the answer is 14.3. So that's the first problem on the study guide. First problem on your test will be a proportion. Just make sure you cross multiply correctly. You're allowed to use calculators on this chapter, so feel free to use a calculator to help calculate. Problem 2. To write a fraction as a percent, first thing we're going to do is make it 13 over 5. 2 times 5 is 10, plus 3 is 13. I just say equals P over 100. So the fraction equals percent over 100. And we just have to cross multiply. So 5 times P is equal to 1,300. We divide both sides by 5. 1,300 divided by 5 is 260. So in general, fraction equals P over 100, cross multiply. If it's a mixed number, improper fraction is better than mixed number. That's the easiest way to do it. Other technique would be to change the fraction to a decimal, then move the decimal point two spaces over. That works also. 2 3/5, I go 5 goes into 3. 5 goes into 3 0 times, 5 goes into 36 times. 30 minus 30 is 0. So 2 3/5 is 2.6 decimal, which is 260%. That way works also. So take your pick. It will be a fraction changed to a percent. That's how you do it. One or the other. I like this way better personally, but I might have shown you that way in class. So number 3. Write 0.5 as a fraction, 0.5% as a fraction of those terms. The way to do this, what I told you in class when we did these, was the word percent means divided by 100. So if I got 0.5%, that's 0.5 divided by 100. So pretend the percent symbol's not there. Put the numerical value that you see over 100. And then you need to make a good fraction out of this. Good fractions do not have decimals in them. So the top has exactly 1 decimal place, so I need the bottom to have exactly 1 decimal place. So I put a 0.0 on that 100. All right? And then, once both the top and the bottom have the same number of decimal places, I just slide them both the same amount over. So slide both decimals 1 space over. I'm going to get positive 5 on top, positive 1,000 on the bottom. And the final step is to reduce the fraction as much as possible. The only thing that divides any power of 10 would be 2 and 5. So you see if 2 or 5 goes in the top number, if it does divide by it, can we all see 5 goes into 5? So I'm simply going to divide the top and bottom by 5 then. So 5 divided by 5, 1,000 divided by 5 to reduce it. 5 divided by 5, of course, is 1. 1,000 divided by 5 is 200. So 0.5% is 1/200. All right, number turn the page, all of a sudden they put word problems on you, right? Like, this is an easy test. Oh no. Anyway, extruded steel rods shrink 12% in cooling from furnace temperature to room temperature. The standard tie rod is 34 inches. Exactly when it is formed, how long will it be after cooling? So, it's shrinking, it's losing mass when it goes through the cooling process, all right? So, what I want to do is, again, all these word problems that we had in this chapter, I try to make a percent sentence problem out of this word problem, right? If it's shrinking 12%, is it getting bigger or smaller? Smaller. So if its original mass is 100% and we're losing 12%, what are we left with? 88% would be left, right? So to do that, we just do 100%. That's where we always start at 100. We're losing 12%. 100 minus 12 is 88%. So if 12% is being lost, 88% is being kept. Okay? It says they shrink 12% from furnace temperature to room temperature. So the original, the furnace temperature to room temperature, it's formed at furnace temperature, and it's going to be cooled to room temperature, right? So the original amount is the whole. So the furnace temperature of the rod is the whole. The room temperature is the part. As always, part is what percent of whole, right? So when we create the sentence. So the whole is 34 inches. The part is what we're looking for. What's the end up after it cools? So what is 88% of 34 inches? It's formed in the furnace, and then it shrinks. So it starts off with that, ends up smaller. So if I create a proportion out of this, fraction bar over 100, 88% goes on top of 100, so 88 goes there. What is, we don't know, of 36 goes on the bottom, is on top of on the bottom. So x over 34 equals 88 over 100, then we simply cross multiply again. This product, 100x, equals that product, 88 times 34. 2,992. So if 100x equals 2,992, decimal point lives right there at the end of the number. Divide by 100 is going to slide the decimal point 2 spaces left, so divide by 100. Divide by 100, we're going to get x equals 29.92 inches.
Mr. Klein.
Yes?
I did a different way from you, and I got the same answer.
Did you do 12% and end up with 4.08 inches, then subtract from 34? That's also a valid way of doing it. Again, as long as you understand the process of what's happening, that's fine. The two ways to deal with a loss or an increase is you find out how much the loss is and then subtract from the whole amount, or you figure out what percent's left and then do it that way. This gets you right to the answer, where your way you have to kind of step through a couple hoops to get there. That's why I prefer this way, but if you understand that way, by all means use your way. And I'm not a big fan of forcing you to do one way or the other. So if you have a technique that works, that you understand, you get the right answer, by all means use your technique. Make sense? Awesome. Number 5. A salesman at the Wasteland TV company sold 5 identical LED TV sets last week and earned $509.70 in commissions. If his commission rate is 6%, what does one of these models cost? And again, we've talked about commission in this chapter. Commission is if you work for a company and you sell some of the company's product, which gets the company lots of money, the company gives you a little chunk of it. That's your commission. This guy's getting 6% commission. He's getting $6 for every $100 he sells. That's what commission is. Every $100 he sells for the company, he gets $6 of it. That's what a 6% commission is. So, with that in mind, if we focus on what's happening here, he sold 5 TVs. They're identical, which means they're the same price. We know how much money he earned in commissions for 5 TV sets, and we know what his commission rate is. We want to know what the total amount of the TVs is. So his commission is what he earns part of everything or the whole amount? Does he earn the whole amount or just part of it?
Part.
He just earns part of it, right? So what he gets in commission is part of the whole, and his part is 6% of the whole. So what I know is that his commission that he got, $509.70, is 6% of what he sold. Again, I want to take the words in the word problem and I want to create a basic percent sentence expression. His commission that he earned is 6% of what he sold. The company gets all the money. They give him some of the money back. So what he's getting is just the part. Part is percent of whole. So I got my proportions set up. I'm going to do fraction bar equals fraction bar over 100. I do all the same stuff I always do. I put the percent on top of 100. I put the is part on top, so $509.70 goes up here. And I put the of part on the bottom. We don't know what he sold. Again, fill in the 3 holes with what you know. 6 times x equals $509.70 times 100, which is $50,970. We divide both sides by 6. And my calculator says 50970 divided by 6 is $8,495. Now, that's how much merchandise he sold. He sold that much worth of merchandise, almost $8,500. The problem asks how much a TV costs. How many TVs?
5.
How many do they want the cost of?
10.
What does one of these
One.
models cost, right? They want the cost of one TV. This is the cost of how many TVs? 5. So to get the cost of one TV, we got to divide the price of 5 TVs by 5, right? So if $8,495 for 5 TVs, I got to do 5 into $8,495. And again, what is it?
1,699.
Every one of those TVs is $1,699. I hope they're nice.
Yeah, they're LED.
Smart TV, probably Bluetooth compatible with a smart speaker. And
Size of the smorgasbord.
it's probably as big as a wall. Maybe it actually comes in like it's an outside TV and it comes in out of the yard, right? So it's like it sinks down into the yard and comes back up and has stereo speakers and stuff on it. That probably costs more than $1,600.
Have you seen those paper thin TVs that are like that thin?
I have not seen
And you
those
can
now.
see through it. It's-
Really?
Yeah.
What kind of TV?
Interesting.
Yeah, I've never.
It's,
now
I'm
one
pretty
of those
sure
TVs,
it's like,
But like when the picture's there, it's
Yeah,
there, but
something
otherwise it's
different.
see-through? Oh, that's
no,
interesting.
not see-through, but like you can see.
Oh God,
like,
yeah.
Okay.
down. Like,
Oh no,
the
same,
crystals.
yeah.
So it's like almost like if you're looking at it that way, it's just like a piece of paper.
Yeah.
I've done
I
it.
got you, okay.
I've
I've not seen those. My guess is more expensive than these.
What are the
But, all right.
electronics though?
Everybody good with that one?
Yeah. Like, where does it all go?
Moving right along. Number 6, a production job is bid at $6,275, but cost overruns amount to 15%. What is the actual job cost? So this does involve a little bit of understanding of vocabulary. Maybe you not know, maybe you don't. I don't know. What does the cost overrun, do you think? Does that mean it costs more or costs less?
Cost more.
Costs more. If it costs overrun, that means that we've already hit the amount. Well, it's going to cost this much money, but hey, we already hit that amount. You can see that your deck's not finished yet, so we're going to have to add something to the estimate. So ideally, when you make an estimate, if you're running a business, you get close to the correct amount, so that people that you're building the stuff for they're not going to be upset. But anyway, overruns 15%. So 15% more is what it's going to cost. So again, there are 2 ways of doing this. We can find out what 15% is, add it to 6,275, or we want to know what is 115% of $6,275. The actual estimate is what it's supposed to cost. That's the whole amount. We're going above that amount, so our part's going to be bigger than 6,275 because we got it bigger than 100%. Again, that's option 1. You can do it that way. The answer you get to this problem is going to be the answer. Option 2, if I just do 15%, that's just how much extra it's going to be. Then you have to add that to the original amount. Take your pick. Again, I usually go with the 115%. I always start at 100, and then it says increases 15%, so I'm going to do plus 15%. That's how I get my 115 in my sentence. Everything's based on 100% starting. I either go up or down if I'm increasing and decreasing it, which is what's happening here. So I got my fraction bar 100, 115% goes right there. What is, we don't know, of 6275, 6275 goes there, is on top of, on the bottom every single time. We cross multiply, 100 times x equals 6275 times 115. 721,625. And if 100x equals that, we divide by 100. The decimal point currently lives right there. Dividing by 100 is going to move it 2 spaces to the left. So the actual cost is going to be $7,216.25. As a general rule with money, round to the nearest cent. This one happened to be right in cents already, but if you get like 4 or 5 decimal places, round to the nearest cent for that, unless specifically told otherwise. Sometimes they say round to the nearest dollar, but anyway. The other way of doing it, we would add 15% would have been like 900 and something dollars, and 900 something dollars out of that would have gotten 7,216. So again, both ways work. I know some use the other way on the decreasing, so you might use the other way on the increasing. So again, use your technique if you get the right answer. Just know how to use it when the test comes about. Number 7. An electrical resistor is rated at 4,500 ohms plus or minus 3%. Express this tolerance in ohms. All right, so first of all, when it says express the tolerance in ohms, that means it wants 4,500 plus or minus some number of ohms. That's what part A is asking us for. They want to know an actual number of ohms as opposed to percent. All right? And then state the actual range of resistance. Once we get that, I'll show you how to do that. You gonna make it, Kevin?
Yeah.
All right. So, first off, this is the rating, 4,500, and then the allowed error is 3%. We can be 3% above or below the error, and the error is always the part. So when we talk about this in class, the part is 3% of the whole, right? So I want to know what is 3% of 4,500. So what is 3% of 4,500? That'll tell me how much error I'm allowed to have. So if I go percent proportion again, 3% goes on top of 100. What is, we don't know, goes on top of 4,500. 4,500 goes in the bottom. We cross multiply, we get 100x equals 3 times 4,500. We divide both sides by 100. We get x equals 135. So 135 ohms is the amount of allowable error. So as far as the tolerance in ohms, we write 4,500 plus or minus 135 ohms. Again, that's what that answer represents. That's what that means. So when you see the problem on the test, it says this thing here, it wants to have the 4,500 plus or minus what the actual amount of ohms is. That's what that question is asking for. And then when it says state the actual range of resistance, all it's asking for is what's the biggest and the smallest number possible. So you're simply going to take the 4,500 and add 135, take the 4,500 and subtract 135. So I'm going to do 4,500 plus 135 and 4,500 minus 135. And use calculators as necessary if you wish. This is 4,635. This is 4,365. So the actual range, small to large, is going to be 4,365 ohms to a maximum of 4,635 ohms. So, acceptable amount plus or minus the error, the actual error ohms, is the tolerance in ohms. Smallest acceptable measure to largest acceptable measure is the range they're looking for. So I'm looking for both those answers on this problem. You do have to find out what the percent is to figure out the amount. So whatever the percent is here, 3%, if it says 9.3%, this is 9.3 instead of 3. Do it the same way. Any concerns on number 7? Continue on, number 8. An electrical shop motor rated at 2.5 horsepower is found to deliver 1.8 horsepower to a vacuum pump when it's connected through a belt drive system. What's the efficiency of the drive system? Efficiency of a system is simply what it is able to do divided by what it is supposed to do equals percent over 100. This is what it actually does. This is what it's supposed to do. So it's supposed to deliver 2.5 horsepower, it only delivers 1.8 horsepower, therefore it's not running at peak efficiency. It's running at some lower percentage from 100, right? If it's delivering 2.5 and it's supposed to deliver 2.5, it's 100%, right? It's not going to be that easy on the test. It's going to be one of these. So anyway, so 1.8, what it's doing divided by 2.5, what it's supposed to do equals percent over 100. Once again, our proportions there, we cross multiply, so 2.5 times P equals 1.8 times 100. Divide both sides by 2.5. Divided by 2.5 is 72. So P is 72%. Time for a tune-up, I think. All right. Number 9. If 60 miles per hour is equivalent to 88 feet per second. Now, this is a unit conversion problem that's a little bit tricky in the wording of it. It's a little bit trickier than you're used to. But what I want you to see about this problem is the equivalency they're telling us. It's saying that 60 miles per hour, this unit of speed, is the same as 88 feet per second, that unit of speed. So if I was to write that down, it looks like this: 60 miles per hour equals 88 feet per second. All right. So I want to express 45 miles per hour in feet per second. So I'm changing from one of those things, miles per hour, to the other thing, feet per second. And again, the way unit conversion works is if something equals something, we can make a fraction. I can just say 60 miles per hour over 88 feet per second, or 88 feet per second over 60 miles per hour. One of those two fractions is equivalent to 1, and one of those two fractions will be what I need to convert from where I'm at to where I want to be. So I'm going to put these on the back burner until I write out my structure, and then I'll determine which one's useful. So 45 miles per hour is where I'm currently at. So 45 miles per hour times something is going to equal the correct number of feet per second. All right, so what I want you to see about this is the unit I'm trying to achieve is feet per second. The unit I currently have is miles per hour, so I want miles per hour to disappear, and I want feet per second to be there, right? So if miles per hour currently lives on the top, I need a miles per hour on the bottom for cancellation purposes. So this is a useful one. This is not useful in this one. If they give me feet per second to change miles per hour, and I want to get feet per second to go away, now I have to use that one. So again, you position where it goes, then you pick the one that makes that go away. So I want miles per hour to go away. This makes miles per hour go away. So 60 miles per hour on the bottom, 88 feet per second on top. Mile per hour on top, mile per hour on the bottom. Cancel, cancel, leave me with that unit, which is what I want. To get the number, once I got everything in the position, things on top multiply, things on bottom divide. So ones don't matter because times 1 doesn't do anything, divided by 1 doesn't do anything, right? So if I see ones, I just ignore ones.
No cross multiply.
Nope. You just multiply things on top, divide by things on the bottom. So 45 times 88 divided by 60. 45 on top, 88 on top, multiply, divide by 60, because this on the bottom equals, the answer is 66. That's the easiest way to do that one. Here's another way that you may have done based on the things we've done in class. This is a proportion class, right? Miles per hour over feet per second. If if we make a ratio. 45 miles per hour, sorry, 60 miles per hour is the same as 88 feet per second. 45 miles per hour is how many feet per second? That works also. Cross multiply, you're still doing 45 times 88 divided by 60. You're getting the same math in it, but it's just a different way to set it up. So if you prefer a proportional way, that's how you do it proportionally. Right, depending on how you set it up, again, do what you need to do. Number 10. A photograph measuring 8 inches wide by 12 inches long must be reduced to a width of 3.5 inches to fit on a printed page. What will be the corresponding length of the reduced photograph? So when you change the dimensions of a photograph, unless you want the person to come out looking really super thin or really super large, if you want their I guess the person to look the same in the picture, you need to adjust both dimensions the same amount, right, by the same factor. So I've got length and width, right? So width is 8 and length is 12. So the original is 8 inches over 12 inches. The new width is 3.5 inches, and the new length is what we don't know. So again, I'm creating a proportion here by structure of things. So I put width over length. So the original over the original equals the new over the new. If I cross multiply, I'm going to get 8 times L, I don't know the length yet, equals 12 times 3.5. That'd be 42. Use a calculator if necessary. The way you do 12 times 3.5 on a calculator, 12 times 3.5. 42. All right. 12 times 7 halves equals 42. Making an improper fraction. 3.5 is 7 halves, right? So times 7 over 2 times 3.5, however you want to do it. 8L equals 42. We divide both sides by 8. Now this is a mixed number, so I'm thinking a mixed number is a good structure to put this in. Whatever degree, 42 over 8 is the same as 21 over 4. Since both numbers are even, I can reduce it by 2. If I go 4 goes into 21, I don't want a decimal, I want a remainder. So 4 goes into 21 5 times 4 is 20, subtract, you get a remainder of 1. So L is going to be 5 1/4 inches. Okay. That'd be at the same ratio of size as the original. Yes, Ashton?
I guess we have the same answer, I just got 5.25.
Yeah, but again, just I'm looking at the structure. That's a mixed number. I'd like a mixed number, just to stay consistent.
So if it is this, it's still correct, but are you gonna find it wrong?
I'd like a mixed number. Give me a mixed number. Maybe it comes out the whole number on the test, who knows? Then it doesn't matter, but I'd rather have a mixed number. All right, number 11. A sprayer discharges 600 cc's of herbicide in 45 seconds. For what period of time should the sprayer be discharged to apply 2,000 cc's of herbicide? And once again, all these are called direct relationships. If one thing gets bigger, the other thing gets bigger. If one thing gets small, the other thing gets small, right? If I've sprayed 600 in 45 seconds, to do 2,000 is going to take more than 45 seconds, right? As one goes up, the other goes up. So if I put my herbicide, 600 cc's of herbicide takes 45 seconds, then 2,000 cc's of herbicide takes how many seconds? Fraction 1 equals fraction 2. Cross multiply, I'm going to get 600x equals 45 times 2,000. Divide both sides by 600. We get 150 seconds. It would be really cool, you can say 2.5 minutes.
I did.
2.5 minutes works too, yeah. What?
So I got everything correct, but instead of putting 2,000 on top on the right side, I put 45, and I put 2,000 on the bottom.
So you put 600 over 2,000 equals 45 over x? Same difference.
I did the
Yeah, either way works.
same.
All right. Number 12, if 6 printing presses can do a certain job in 2.5 hours, how long will it take 4 presses to do the same job? So look at this one. Again, think about direct relationships that I just talked about. When one number gets bigger, the other number gets bigger. When one number gets small, the other gets smaller, right? This is an inverse relationship. If I have a job to do and I'm one person doing it, and then I have the same job to do and I got more people doing it, it's going to take less time with more people or more time. So I got one job to do, let's say I've got 2 people to do one job.
It's gonna go faster.
And then if I take 5 people to do the same job, it's going to take less time, right? So when I make the number of people go up, the amount of time goes down, right? That's an inverse relationship. One number goes up, the other number comes down. That's what's happening here. 6 printing presses are doing the job in 2.5 hours. 4 presses should take more time, right? If 6 can get the job done in 2.5 hours, 4 presses should take longer to do it. So, with that in mind, the way an inverse relationship works is like this. I'm going to put 6 and 2 1/2, this and this, diagonal to one another. And then the 4 presses diagonal to the time it takes for 4 presses. Direct relationship, they would have been directly across from each other. Inverse, they invert. So you're going to have diagonal to one another. So now if I cross multiply, I get 4 times t equals 6 times 2 1/2. That'd be 15. Divided by 4. Once again, this is a mixed number, so a mixed number seems appropriate for this one. If I go 4 goes into 15, 3 times, remainder 3, so t is equal to 3 3/4 hours. What?
What happens if I got the same answer, but I did it like 3.75?
Same thing I told Ashton. I see a mixed number of a problem, I want to see a mixed number of the answer. It's not wrong. I probably wouldn't even count it wrong, I wouldn't count points off, but it's just good math to consistently stay within the same number frame that they're using. So 3.75 is not wrong. If you did that, you got the right answer, you know what you're doing, that's great. But try to match the structure of the numbers in your answers when you do it. All right? It'd be mean for me to count it wrong because it's not wrong.
Mm-hmm.
But just it's better policy to have the same structure. So try and make a habit of doing that. But if you have the right answer, I'm going to count it right. Fair enough. Number 13. A certain concrete mix requires 1 sack of cement for every 650 pounds of concrete. How many sacks of cement are needed for 3,875? So if I need more concrete, I need more sacks of cement, right? So that's a direct relationship. One goes up, the other goes up, one goes down, the other goes down. So 650 pounds goes with 1 sack, 3,875 pounds goes with I don't know how many sacks. There's a hint here. Remember, you cannot buy a fraction of a sack. So if you have to get point anything, you're going to have to round up to the next number, no matter what it is. If you get 6.043, you got to get 7 bags. If you get 6.993, you got to get 7 bags. So any part above, you got to get the next bag up. So if I cross multiply, I get 650x equals 3,875. Divide both sides by 650, and we divide on the calculator. 3,875 divided by 650 comes out to 5.96 bags. And again, we can't have a fraction of a bag, so I would say 6 bags or 6 sacks of cement. We won't have enough cement to do the job. We have to round up. Do not round down. Number 14. The current in a certain electrical circuit is inversely proportional to the line voltage. They're telling us this. So the last 4 or 5 we've had to determine direct or inverse. This is actually telling us inverse. So current, first current over second current, is inversely proportional to line voltage, voltage 2 over voltage 1. That's what an inverse proportion looks like. The initial over the final of the first thing equals final over initial of the second thing. Then we just have to put in the numbers. A current of 0.40 amps, that's my first current, is delivered at 440 volts, that's my first voltage. What is the current? That's C2 if the voltage is 120. Kevin.
Oh my God.
Erica can't hear me over all the snoring. Trying to stay awake. So, first current, first voltage, second current, we don't know second voltage. So again, it's inversely related. Cross multiply C2 times 120 equals 440 times 0.40, which is 176. We divide both sides by 120. And 176 divided by 120. Comes out to 1.47, round to the nearest one. Yeah. So C2 is equal to 1.47 amps. It says round to the nearest 0.01 amps, so round to the 2 decimal places. So
Oh, I got it.
1.4666666666, right? So 1.47 is what it rounds to. And, oh, I have a minute to spare maybe. Number 15.
Oh my gosh. I got the answer correct.
Closed container, the pressure is inversely proportional to the volume when the temperature is held constant. So, pressure is inversely proportional to volume. That means P1 over P2 equals V2 over V1. Again, that's all it means. The subscripts get inverted. The first pressure is diagonal to the first volume. The second pressure is diagonal to the second volume. When the temperature is held constant, we're assuming the temperature is held constant here because it doesn't mention it. So it says find the pressure of a gas compressed, pretend it says compressed, to 0.386 cubic feet if the pressure is 12.86 psi at 2.52 cubic feet. So we can call this P1 V1. So 12.86 2.52. V2 is 0.386. P2 is what we're looking for. These go together, those go diagonal. The one we don't know and that go together, they go diagonal. So 0.386 P2 equals whatever 12.86 times 2.52 is. 32.4072. So we get the answer, we divide by 0.386. So we take that, divide it by 0.386, and we get 83.96. And pressure is in PSI, so that's PSI.
Hey, Mr. Cohen, this is an assignment that we did yesterday, is not due today.